If I lift an object up a height h for an appropriate choice of system, there can be said to be a gain in potential energy. Maybe I should have said gravitational potential energy there. Does it matter exactly what path the object takes as long as I bring it to the same height h above where it started? So in the last example, we were talking about an object going through a distance y, but what if I renamed that h, okay, and said this is the distance I lifted it. I have this potential energy function, u sub g of y is equal to mgy, but really when I said h over here, that's like saying, okay, so y is equal to h implies that the gravitational potential energy as a function of that h is equal to mgh. And that's the formula we already used before we got so formal about this stuff. But what this question is really about, though, because like we argued that this function had to be what it is based on the amount of work it would take for me to do this. What if instead of lifting it straight up, what if I followed a path kind of like this, right? What if I followed some crazier path? What if I first went down, then I went over here, and for some reason I went over here and I still wound up at the same spot? Does it matter what path I took to get to this final position to state how much gravitational potential energy this system has? And it says for an appropriate choice of system. So when I say this system, I mean the object plus gravity, because we've discussed that gravity needs to be included in a formal description of that system. But the answer is no. It shouldn't matter, because the amount of energy stored in gravitational potential energy only depends on the position of the object. It doesn't matter how it got there. So anyway, that's the answer I'm giving. So it says no, it does not. This is a general property of a potential energy based on a conservative force.